So today we are going to study the chapter Atoms and Molecules. Okay, so during the 500 BC there was an Indian rishi known as the Maharishi Kant. So he told that if we start continuously dividing the matter at the end, that is, he called the matter as Padarth. He stated that if we are continuously dividing the Padarth, finally we will get a substance that is further undivisible, and he called that substance as Parmanu. Okay, and later on Greek philosophers named as Leucippus and Democritus called this same Parmanu as atoms. Okay, and further on a scientist named as Antoine Lavoisier laid the foundation of chemical laws. What is the name of the scientist? Antoine Lavoisier. Okay, he laid the foundation of chemical science by establishing the laws of chemical combination. So because of that we are going to study this chapter. So coming to what are atoms? What are known as atoms? All the matter around us, whether it be this pen, this board, this wall, anything, all the matter around us is made up of tiny particles known as atoms. So atoms can be called as what? Building blocks of matter. Okay, building blocks of matter. And these atoms are the smallest particle that takes place in a chemical reaction. If there is a chemical reaction, what is the smallest particle that is taking place in that? It is the atoms. It is smallest particle taking place in a chemical reaction. Okay. Next, these atoms are so small, that is, they are very tiny, that we cannot see them with our naked eyes, as well as even using the powerful microscopes we can't see these atoms. Okay, so what will be the range of radius of these atoms? It will be in the range of nanometers. Okay, it is not centimeter, it is not millimeter, it is not meter, it is in the range of nanometers. And what is nanometer? What is a nanometer? See, 10 raised to 9 nanometers is equal to 1 meter. Followed. That means, what is 1 nanometer? 1 nanometer. 1 nanometer is equal to 1 by 10 raised to 9 meters. Followed. Okay. So, in your Ncert, there is a small table given. In it, all the relative sizes of what? Some of the atoms like hydrogen, then molecule of water, all this is mentioned. Okay, so you can see that the radius size of a hydrogen atom is given as 10 raised to minus 10 nanometer. Okay, so you can imagine how tiny will be these atoms. Okay, now we are coming to the first topic of this chapter, laws of chemical combination. Okay, laws of chemical combination. These laws were stated by who? Antoine Lavoisier and Joseph Proust. Okay, so in the laws of chemical combination, there are two laws coming under the heading of laws of chemical combination. There are two laws. The first one is law of what? Law of conservation of mass. Law of conservation of mass. And the second one is laws of constant proportion. Okay, this law, no, this law of constant proportion, this was stated by Joseph L. Proust. Okay, now we are going to see what is known as law of conservation of mass. Okay, see, now let's consider a chemical reaction. In that reaction, I am taking 20 grams of a reactant A. Okay, I am combining this 20 grams of reactant A with 30 grams of reactant B. I am getting a product C. Can you guess what will be the mass of this product? Yes, according to the law of conservation of mass, the total mass of the reactants will always be equal to the total mass of the products. So, what is the total mass of the reactants here? It is 20 plus 30 is 50 grams, right? So, as per this mass should be present on the product side as well. So, if the product is C, the mass will be 50 grams. Followed. Similarly, if suppose it is a decomposition reaction, I am telling let a product D, it is decomposing. This is of 100 grams. Okay, it is decomposing to form two other components E and F. Let E be 30 grams. Then what will be the mass of F? According to the law of conservation of mass, total mass of the reactants is equal to the total mass of the products. So here it is 100. So 30 is here. So what will be the mass of F? It will be 100 minus 30. That is equal to 70 grams. Okay, followed. So what is known as law of conservation of mass? What is known as law of conservation of mass? In a chemical reaction, the total mass of the reactants will always be equal to the total mass of the products. Okay, this is very important. Total mass of the reactants will always be equal to the total mass of the products. Followed. So this is all about law of conservation of mass. Next we are coming to the second law, that is what? Law of constant proportion. Okay. What do you mean by this? Law of constant proportion. Okay, for example, we are taking the case of water. Okay, what is the chemical formula for water? You might be knowing it is H2O. Okay. So, see, suppose I'm having more hydrogen. I'm having more hydrogen. Okay, or in a chemical reaction there are 3 hydrogen atoms. 3 hydrogen atoms is coming to react with 1 atom of oxygen. Okay, will the water be formed as H3O? No. Okay. Now let's come to the second law, which is coming under laws of chemical combination. That is what? Law of constant proportion. So what do you mean by law of constant proportion? Okay, for example, let us take the case of carbon dioxide. What is the molecular chemical formula for carbon dioxide? It is CO2, right? So whatever be the situation, what if suppose there is lot of carbon? For example, let's take in a reaction, if 2 atoms of carbon is coming and we are having 2 atoms of oxygen as well, will ever the carbon dioxide be formed as C2O2? No. How many carbon atoms are there? That doesn't matter. Carbon dioxide is always formed as CO2, right? And also, see, the gas which I am giving out during respiration is carbon dioxide. What you are giving out is also carbon dioxide. Is there any difference in the chemical formula of the carbon dioxide that I am giving out and you are giving out? No. It's all the same, right? Same is the case with water. What is the chemical formula of water? It is H2O. Water, the chemical formula of water is always H2O, whether it be the water in my home or whether it be the water in your home. Okay, the water's chemical formula is always same. So what does that state? It states that the elements of a pure chemical compound is always present in constant proportion by mass. So what does it state? The elements in a pure chemical compound is always present in same, or what? We can write what? Yeah, same proportion by mass. This is very important. Proportion by mass. What does that mean? See, I'm taking the case of H2O. In molecule H2O, what is the mass of hydrogen? Okay, see, there are 2 atoms of hydrogen. So 2 into, what is the atomic mass of hydrogen? 1. Followed. Now, what is the mass of oxygen here? What is the atomic mass of oxygen? It is 16. So here the hydrogen is 2 gram and oxygen is 16 grams. What is the ratio of their mass? 2 is to 16, which is equal to 1 is to 8. So this law states that the ratio in which the hydrogen and oxygen combine to form water will always be a constant. So it will be always what? 1 is to 8. Let's see another case. See, we are taking 36 grams of H2O. Okay, means what? It is 2 molecules of H2O. Here, what is the mass of hydrogen? There are 4 molecules of hydrogen. So the mass will be 4 into 1 is 4 grams. Okay. Now, how many molecules of oxygen is there? 2. So the mass of oxygen will be 2 into 16, that is equal to 32 grams. Now, what is the ratio between hydrogen and oxygen? 4 ones are 4, 4 eights are, that is 1 is to 8. So how many molecules it be? Here we took only 1 molecule, here we took 2 molecules, but the ratio between the masses of hydrogen and oxygen is always constant, that is 1 is to 8. Followed. Okay. Now we are coming to the next topic, Dalton's atomic theory. So, what does Dalton's atomic theory states? It states that all matters, whether it be element, compound or any mixture, all are made up of atoms. Okay, all matter, whether an element, compound or mixture, is composed of small particles called as atoms. Okay, so when Dalton stated this theory, there are 6 postulates. Okay, 6 postulates for Dalton's atomic theory. Let's see what are the 6 postulates. The first one is atoms are all matter is made up of atoms. Okay, he stated that all the matter around us is made up of atoms. And what is the second postulate? Atoms are indivisible. Means what? It cannot be created or destroyed in a chemical reaction. So that is the second postulate. So what is the third postulate? The third postulate states that all the atoms of a same element will be identical in mass and they have the same chemical properties. That is, for example, the atom of hydrogen. All the atoms of hydrogen will be same, similar in what? Mass and chemical properties. Okay. And what is the fourth postulate? The fourth postulate is that the atoms of different elements will be different in mass and different in chemical properties. Okay. So these are the four postulates. Now coming to the fifth one. What is the fifth one? The atoms are combining in a ratio of small whole numbers to form compounds. That means what? See, example in H2O. Is the formula H2.5O? Is the hydrogen combining in H2.5O? No. It is combining in small whole numbers. Right. So that is the meaning of the fifth one. Now coming to the sixth postulate. The relative number and kinds of atoms are constant in a given compound. That is what? See, if the compound is water, we are taking water. The atoms are constant in all the water molecules. That is, if water is H2O means all the water will be H2O only. Okay, followed. So, these are the 6 postulates of Dalton's atomic theory. So, now we are going to study what are the drawbacks of Dalton's atomic theory. What did Dalton's atomic theory state? Atoms are indivisible. That means it can be divided further. But later on, studies prove that atoms contain subatomic particles. So, did his theory explain about subatomic particles? No. So, that was the first drawback. Not explained subatomic particles. Subatomic particles. Like what? Like electrons, protons, neutrons. Okay. So, actually atom contains of what? The structure of atom is what? It has a nucleus in the center and the electrons are revolving around the orbit outside the nucleus. And inside the nucleus there is what? Electrons, protons and all. Sorry, neutrons and protons. Okay. So, Dalton's atomic theory stated that atoms are indivisible, which means there is no subatomic particles. But later on studies prove that again this atom consists of many small things like electrons, protons and all. So, that was the first drawback. His theory was unable to explain about the subatomic particles like electrons, protons, neutrons, nucleus, etc. Okay. Now, what was the second drawback? His theory did not explain about isotopes. Okay. What is the meaning of isotope? Have you heard about protium, deuterium, tritium? See, all these are atoms of hydrogen. Okay, all these atoms of hydrogen with same atomic number and different mass number. Okay, so what are known as isotopes? Atoms with same atomic number and different mass number. Okay, what does this signify? See, the atomic number always refers to the number of protons inside the atom. Okay, so this is the number of protons, and mass number is the sum of protons plus neutrons. Suppose there is an atom. This is an atom of hydrogen. Okay, see, the atom contains a nucleus and the nucleus will be having all the positively charged protons and the nil charged neutrons, and the orbits outside it will be containing the electrons. So suppose I am drawing the structure of protium. See, what are the number of protons? The number of protons is equal to the atomic number. Okay, so proton will be equal to 1. Number of electrons is equal to what? Number of protons. So how many protons are there? 1. So the number of electron will also be 1. Now coming to neutrons. What is mass number? This sum of protons plus neutrons. So to get neutrons, you have to subtract number of protons from mass number, which means 1 minus 1 is equal to 0. Followed. So this is the structure of the protium. Now if you are drawing the structure of deuterium, see, what is the number of protons? Number of protons is equal to the atomic number 1. Number of neutrons is equal to mass number minus atomic number. That is 2 minus 1 is equal to 1. Number of electrons is always equal to the number of protons. So number of electron equal to 1. Followed. This is the structure of H12. Similarly, try drawing the structure of tritium. Try drawing by your own. So these are known as isotopes. So Dalton's theory was unable to explain about isotopes. Now, what is the third drawback? Similarly, like isotopes, there is one more thing known as isobars. So his theory was not able to explain about isobars. Okay, did not explain isobars. What are isobars? Now see, isotopes are atoms with same atomic number, different mass number. Now isobars are atoms with different atomic number and same mass number. Example, what is the atomic number of argon? 80. What is the atomic number of calcium? 20. See, different atomic number. Now the mass number 40. These to see. In here the atomic number is different but the mass number is same. Okay. So such kind of atoms are known as what? Isobars. Followed. They are isobars. So his theory was not able to explain isotopes and isobars. Then what is another drawback? Okay, just put like this, not explain. See, have you heard about allotropes? Allotropes. So even his theory was not able to explain allotropes. What are allotropes? Have you heard about diamond and graphite? What is diamond and graphite? Yeah, they are made up of what? Same carbon. Okay, they are made up of same carbon. But are both same? No, both have different properties. Diamond is the hardest. Graphite is the softest. Graphite is soft. Okay. Why? What is the difference here? See, even though it is made up of chains of carbon, the arrangement of carbon is different in both the cases. Okay. In diamond, the carbon is forming bond with 4 other carbon and this goes on like this. Okay. Somewhat you will study about this in 10th standard. Now, if you are coming to graphite, the carbon is forming chains like a ring. Okay, it's forming chains like a ring. See, at all this point there is a carbon. Okay, carbon. So, even though both are made up of carbon, because of the arrangement of the carbon atoms, both exhibit different physical properties. So, diamond and graphite are allotropes. Understood? So, what are allotropes? Okay, so This is an example of allotrope. So this Dalton's theory was unable to explain about allotropes as well. Now coming to the fifth drawback. His theory stated that atoms combine in small numbers of whole number ratio, right? Small whole number ratios. But in some complex sugar and all, no. This rule does not follow. So, whole number ratio does not, can be violated sometimes. Whole number ratio rule can be violated sometimes in certain complex sugars and all. Okay, so these are the drawbacks of Dalton's atomic theory. Okay, now tell me, see, now we are coming to the modern day symbols of atoms. Next topic is modern day symbols. Okay, see, suppose if you have to denote all the elements in the periodic table, if you want to tell hydrogen is combining with chlorine, then you have to write hydrogen, HYDROGEN plus chlorine, whether it is convenient. So it is not convenient. So to make these things convenient, Dalton proposed that we shall use what? Symbols. Okay, Dalton proposed that we shall use symbols for the element. Like suppose if we are taking hydrogen, it can be denoted as what? H or some symbols. Okay. But the problem came, there was confusion again, because see, what is the second element? It is helium. If you are taking H first letter, then again helium will be capital H. So to avoid this confusion, it was further proposed that we shall take first two letters, okay, to represent. So helium is represented like this. Am I right? See, what can you observe from here? The first letter is capital and the second letter is small. This rule is followed everywhere while writing the symbols of the elements. Okay. So this was proposed by Mr. Berzelius. Berzelius told that we shall use first two letters. Okay, first two letters for representing the elements. Next, see, the naming is not always like if it is helium He. That's right. But suppose how is potassium represented? Is potassium the spelling of potassium is PO, potassium, right? But are we representing potassium by PO? No, the potassium is represented by K. How? See, in certain cases, elements are also known by their like Greek, Latin, German names, etc. Okay, so the name for potassium, another name for potassium is kalium. So from this kalium, this potassium got the alphabet K. Okay. So their names from what? German, Latin, and Greek names are also used. They are okay. Now there is one more thing mentioned about copper. See, some elements are named from the place of their discovery. Example, copper. Copper was discovered from the place Cyprus. Okay, so copper got symbol Cu. Okay. Okay. So can you tell me few of the elements how they are represented? Okay, let's see. Atomic number 1, hydrogen. 1, hydrogen is represented as H. 2, helium, He. 3, lithium, 4 beryllium, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, 10 neon. Followed. Similarly, you have to study at least the symbols and atomic number of at least 30 elements. Okay. Study for about 30 till atomic number 30. Okay.